Hello everybody. Today we're going to be taking a look at some trigonometry story problems. So you're going to need your calculator, something to write with, as well as those guided note papers that have these story problems written on there. So all you have to do is draw the picture, calculate the answer with me, and those will count as your notes today. So trigonometry in ancient times was often used to measure objects that could not otherwise be measured. If I wanted to find the height of a mountain, I would not actually physically climb the mountain. That sort of idea. So we can set up trigonometry ratios to help us find missing measurements if we can view the situation in terms of a right triangle. Let's take a look at a few examples that you have. At a point on the ground 50 feet from the foot of a tree, the angle of elevation to the top of the tree is 53 degrees. Find the height of the tree. So first thing we would want to do is draw a picture of this situation so we can see the exact triangle that we're looking at. So here's my ground, base of my tree here, got a little greenery on the tree, that looks lovely, and we need a point 50 feet from the foot of the tree. So I'm going to say that right about there is 50 feet away from the base of the tree there. Now it says the angle of elevation to the top of the tree is 53 degrees. Elevation, the angle of elevation means going up to the top of the tree. So that angle right there is 53 degrees. And then it's asking us to find the height of the tree. So if we finish the triangle here by drawing a line straight down to the base, this would be the right angle, and we would be looking for the height of that tree right there. That would be labeled with our X. So now looking where we're at the 53 degrees and what we're given, the X and the 50, we should be asking ourselves which ratio will we set up to solve this problem. If we're at the 53 degree angle, X is opposite me, 50 is adjacent to me, so we're going to set up the tangent. Tangent 53 degrees equals opposite over adjacent. So now we would go to our calculator and type in what is the tangent of 53 degrees. And that is 1.3270 equals x over 50. Place this over 1 and cross multiply. 1 times x is x. And that decimal times 50 is 66.4 feet. So the height of the tree is approximately 66.4 feet. Let's look at our second example. So now let's pretend we're in Washington, D.C., and the Washington Monument is 555 feet tall. We're looking up at an angle of elevation of 75 degrees, and we need to find out how far we are away from the base, assuming my eyes are 5 feet from the ground. So let's draw a picture of this situation. Here's the ground. Here's my Washington Monument here. That's a rough sketch. Whoa. A really rough sketch. Let's try that again. A little better. 555 feet tall, Washington Monument, and we are here. This is you, okay? You are looking up at the Washington Monument at an angle of 75 degrees. Now, if we place the 75 here, that's where it is. It's by my eyes, my line of sight, but I don't have a bottom portion, a bottom side of my angle. That's because we need to consider our normal line of sight. My normal line of sight is when my eyes look straight ahead like this. That's my normal line of sight, straight ahead. But instead, I'm looking up at that 75 degree angle that you now see. So that angle is occurring at my eyes, not down at my feet, okay? So it also told me that my eyes are 5 feet from the ground. So I'm going to place that measurement in here too. 5 feet from the ground right there. So this is a picture of the situation, and we need to try to find out how far we are away from the base of the monument, so we need this x value right here. So when we look at where we're at this angle here, and we have opposite given and adjacent, we know we're going to set up the tangent. So tangent 75 degrees equals. Now be careful with your setup. Remember, we're always looking for the triangle in our picture. If I complete this triangle here, over to my normal line of sight, did I use all 555 feet for that up and down side of my triangle, the height of my triangle here? And the answer is no. Remember, my eyes are 5 feet from the ground. that means that this right here is really only 550 feet, not the full 555. So the side of my triangle that is opposite my 75-degree angle is 550, and the adjacent is x. So now we'll go and ask our calculator what is the tangent of 75. The calculator says 3.7320 equals 550 over x. And then we go ahead and place them over 1 and cross multiply. 1 times 550 is 550. That times x, 3.7320x, dividing by that decimal. So 550 divided by 3.7320, let's try to say that right, is 147.4 feet. So we are standing 147.4 feet away from the Washington Monument. Let's take a look at a third example. Now we're going to the Statue of Liberty. So we are standing 100 feet from the Statue of Liberty. And my eyes are again 5 feet from the ground, and the statue is 305 feet tall. What is the angle of elevation from your line of sight to the top of the statue? So at what angle are we looking up? So a similar sort of situation here. We're looking up at something. Here's my Statue of Liberty. Very rough sketch. Holding her torch. Okay, Statue of Liberty. And over here, that's me. The ground. Okay? So, Statue of Liberty, very rough sketch, mind you. You're standing 100 feet from the Statue of Liberty, so I'm going to place that measurement on there. My eyes are 5 feet from the ground again. 5 feet. And the statue is 305 feet tall. Top to bottom. And we need to try to find out the angle that I'm going to end up looking up to see the very top of the Statue of Liberty. So let's draw that in. So I'm going to be looking up to the top of the Statue of Liberty, just like the last one, normal line of sight right here. There is my completed triangle. Here's the 90-degree angle. We know that this would be 100 feet. And we know that this is not 305 feet up and down here, but rather 300 feet. And we're now looking for the angle of elevation. So we're asking ourselves, what is this theta right here? What is that? What is that x? Okay, what is that going to be when we look up at that Statue of Liberty? So we're again, looks like we're going to set up another tangent, opposite over adjacent. So we'll do tangent of the theta equals opposite over adjacent. So tangent of theta equals opposite over adjacent. Now you can't just type in tangent of theta in here. We need to usually tell the calculator what angle we're at. This time we're solving for the angle. That's when you use the inverse tangent of both sides. The inverse tangent here leaves me with theta, so it'll tell me my angle, and then I need to type in the inverse tangent of 300 over 100, which is the same thing as 3, and the calculator will tell me 71.6 degrees. So I'm looking up at a 71.6 degree angle. And our last story problem, ladies and gentlemen. A 60-foot lighthouse sits atop a 150-foot cliff. The angle of depression to a boat is 27 degrees. Find the distance from the boat to the base of the cliff. So we need to draw a picture of this situation as well. First thing I would need, a cliff. And then it is 150 feet tall. Then I need a lighthouse. There's my lighthouse. And that is 60 feet tall. And we are going to be looking at a boat, it looks like. So there must be some water. And then there would be a boat. Rough sketch. And we know that the angle of depression to the boat is 27 degrees. So we must be looking down from the very top of the lighthouse here, looking down to the boat at an angle of depression this time. So rather than elevation, rather than looking up, the angle of depression is 27 degrees, so it's a downward look. Now, this is tricky because you got to be careful where you put the 27 degrees. Remember on those last two problems, we had to consider our normal line of sight? The normal line of sight, the horizontal from the lighthouse up here, or whoever's in the lighthouse, would be straight ahead like this. So if they're looking downward, the angle of depression is actually that measurement there. It's actually 27 degrees out here. From normal looking straight ahead to turning my head downward, that's the angle of depression out here. So is the angle of depression in my triangle up by that lighthouse? No, it's actually not. It's not there where I think it normally would be. So when I complete my triangle here, I'm going to draw the bottom, show my 90-degree corner here, and then we'll go ahead and draw all the way up, or think all the way up. I might even draw my corner in there. There we go. Like that. How tall is my triangle here? 150 plus 60 more would be 210 total. So 210 feet up and down. Angle of depression, we just said where that's at, but that's not the one that's in the triangle right here. We might want to figure out how many degrees that angle would be. Well, if that one on the outside is 27, and we know that these two together have to make 90, I can take 90 minus 27, and this angle actually is 63 degrees right here. And that could be helpful for us. Could be helpful, because what we're trying to do is find the distance from the boat to the cliff. That's the x that we're looking for. So think about that 63-degree angle now that we figured out was in the triangle, even though it wasn't mentioned in the problem. If we look across from that, there's my x. Adjacent is my 210. So again, we're going to do a tangent. Tangent of 63 degrees equals the opposite side over the adjacent side. So now if I ask my calculator, tangent 63 degrees is 1.9626 equals x over 210. Place this over 1, cross multiply, multiply that funny decimal times 210, and we get 412.1 feet. So that boat is a little over 400 feet away from the base of the cliff. So be careful when you set up these angle of elevation and depression problems. It can be a little tricky, but as long as you have a good picture and you can see the triangle within, you got a good start. Okay, we'll continue to practice on these. Thank you for taking good notes.